Hey guys! Christmas came early this year. On May 24th, Epic released 4 marketing videos for Unreal Engine 5. A few hours later, they announced a UE5 livestream with a cryptic title coming 2 days later. Towards the end of that short 15-minute livestream, we found out UE5 Early Access was already available. Ever since then, my team has been experimenting with the new features in Unreal Engine 5, and we'd like to share some of what we have found. A special thanks to Epic for giving a mega grant to my open world server system. OWS is now open source due to that grant, and it also helps me bring content like this to you. If you aren't already aware of my Let's Make an MMO in UE4 tutorial series on YouTube, be sure to check it out. What is a persistent world multiplayer game? I don't really like to use the word MMO because I feel like it is too vague and means too many things to different people. So instead, I classify persistent world multiplayer games as those that use a dedicated server networking model, allow you to play with your friends, and where game progress is saved and generally doesn't reset. This allows a wide range of games to fall into this category. Traditional MMOs like World of Warcraft and Final Fantasy XIV, hub world MMOs like Monster Hunter World Online or Destiny 2, self-hosted survival games like Ark, Atlas, or Valheim, and possibly even some co-op multi-world games like Genshin Impact, if they use a dedicated server networking model. I want to start out by mentioning that the new features in UE5 require a powerful PC to run. NANITE, LUMEN, and virtual shadow maps are forward-looking technology. These features are targeting next-gen consoles like the PlayStation 5 and Xbox Series X and high-end PCs. What do we mean by high-end PC? Well, the minimum PC requirements are something around a GTX 1080 with 8 gig of video RAM, or an equivalent AMD card with that amount of RAM, 6 plus CPU cores, 16 gigs of RAM, and a solid-state drive. These are just what it takes to run the game. Working with these features in Editor takes even more power. In particular, 16 gigs of RAM is going to be really low. I think you're going to want at least 32 to work on games in UE5. I've got a performance test here just to show you kind of the range you're able to get to. So in this small demo here using NANITE, we're getting 90 frames per second at 4K. And we do that using DLSS balanced mode. And the system specs for this was a 2080 Super, a AMD 3900X 12-core CPU, 64 gigs of RAM, and it was running a PCIe 3 M2 SSD, so probably around 3.5 gigs per second, rather than the higher speed PCIe 4 SSD. So this is a small world that we tested here, but we actually found that it scales pretty well, and so even a very large world with hundreds of thousands of NANITE meshes, we're still getting 90 to 100 frames per second, so it does scale well. How does Unreal Engine 5 impact persistent world multiplayer games? Here's some of the big ones. So world partition gives us better management of large worlds. NANITE allows larger, more detailed worlds. LUMEN finally gives us fully dynamic lighting with a global illumination. LUMEN also allows outdoor and indoor lighting to work with the same settings. So in the past, we were not able to have a smooth transition from an outdoor environment into a cave and back out to an outdoor environment. Now we do. And we also used to have issues in Unreal Engine 4 with dynamic lighting where the interiors of buildings just never looked right with the same outdoor lighting settings, and so we had to bake interior lighting. With Lumen, we no longer have to do that. Virtual shadow maps give us a unified shadow solution, and we no longer have to blend cascade, distance field shadows, and far cascades like what we were doing in the past. World Partition is a new distance-based level streaming system that provides a more complete solution than world composition. If you've seen my video 8 in my tutorial series, I talk about how to build huge worlds with very large landscapes using world composition, where we render the landscape only in a small area around the player, and then all of the other world composition tiles are rendered with low poly static meshes that are HLOD'S. Using that method, which worked fine and ran very quickly, there was a lot of manual processes and a lot of other things that you had to do. World Partition is just the evolution of that, and it's now a more complete system. World Partition must be enabled in your project settings before you create your level. If you need to enable it on an existing level, you must run a special commandlet. The commandlet didn't work for us, but that might be because we had a complex 400 tile map using world composition. We also ran into issues when using SVN source control. The commandlet had trouble with that. World Partition allows you to bake World Partition cells for display in the distance with 3 modes. So this is basically generating the HLOD version in the distance for each one of these World Partition tiles. There are 3 different modes. Instancing, where it takes static meshes turned into instant static meshes at minimum LOD. This works good for foliage and nanite. Merged mesh takes static meshes and merges into a single proxy mesh. So you're reducing the number of draw calls, but you're not reducing the number of vertices. I can't think of a great use for this. One might be a modular built city where you don't want to LOD things down, but I'm not really sure why you would do that. And with the new technology, you would just use nanite for those pieces. And the final one is simplified mesh, where static meshes are merged into a single proxy mesh, and then the mesh is simplified. This is the equivalent of what we were doing with the landscape with world composition in Unreal Engine 4, and this will be used in Unreal Engine 5 to also produce landscape tiles in the distance. Unfortunately, this is not currently working. Each HLOD layer can have its own mode, and then the world, data layers, and actors can be added to that HLOD layer. So what you'll see is that if you go to world settings, data layers, and actors, and you scroll down in their settings, you'll see that there's a reference to an HLOD layer that you're adding it to. So you have 3 different ways you can do that. You can take the whole world and apply it to a layer. You can take an HLOD layer, and then you can take a single data layer and apply it to an HLOD layer, or you can go all the way down to the per actor level and assign each actor to an HLOD layer. So you have a lot of control there. Currently, you can't, let's see here. Okay, yep. Now, the loading range that's mentioned here is the range it will load up to. This is a bit confusing because we often want all the tiles to always load, otherwise objects will disappear in the distance. You can enable this functionality by checking the always loaded checkbox, or setting a large loading range such as the world max size of 2 million units. Currently, you cannot bake HLODs in the UE5 editor like you could in UE4. Hopefully this will change in the future. For now, here are the commands you need to run outside the editor. Watch the air count closely in the log. We have noticed that these commandlets don't seem to play nicely with SVN source control. So you may have to run this on a project not under source control, or check out the entire external actors folder before running these commandlets. Baked HLODs show up in your world outliner like this. You cannot delete them from the world outliner though. To remove them, you will need to use the delete commandlet from the previous slide. Our testing has shown that NANITE works very well. We can build out large detailed worlds without having to worry about our performance dropping as we add more detail. Because of how virtual geometry works, once you reach a certain amount of detail, adding more doesn't seem to cost more. NANITE allows very high static mesh vertex count and instance counts. We were able to run hundreds of thousands of instances without much of a performance impact. Go crazy. Fill your world with detail. Since mesh geometry is streamed from disk at runtime, be sure to run as fast of M2 SSD as you can. A 7 gig a second SSD like the Samsung 980 Pro would be ideal. Epic has said that once you use any nanite static mesh in your scene, it is best to use nanite for all your static meshes, regardless of their detail level. This means if you have a 6-sided cube somewhere in your scene, be sure to check that nanite checkbox. Nanite scales based on screen size. Use the DLSS plugin for video cards that support RTX, or the temporal super resolution for other cards when rendering in 4K, potentially even in 2K. And if you're really having performance issues, maybe even in HD. But because nanite scales based on screen size, and 4K is 4 1K screens, so 4 HD screens, when you increase your screen size to 4K, the frame per second just dives. And so using either the DLSS plugin or the temporal super resolution is kind of a must to getting this to work, nanite to work at 4K. Since we want to use nanite for everything for optimum performance, but landscapes don't currently use nanite, we experimented with the possibility of using nanite meshes to replace landscape. Sections of landscape that are covered in grass or other foliage can be sculpted as static meshes. One feature we found missing in Unreal Engine 5 is the ability to export a landscape to a static mesh. This existed in Unreal Engine 4, I believe it was in the Levels window. It's possible you could build your landscape in Unreal Engine 4, use the Export to Static Mesh tool to take sections of the landscape and convert them to static mesh. Then import those static meshes into Unreal Engine 5 as nanite meshes. Another option we played around with was using small chunks of nanite geometry in a blueprint spawner to use as floor tiles in place of landscape. Here is a simple example of that. So you can see I built a blueprint, and we have settings like number to spawn, X and Y, the mesh to spawn, distance between rotation per mesh, things like that. We have a different random seed that I can adjust, and even a list of tiles not to load, so there can be holes and other spots. Now in this example, I just did a big sheet to kind of show you. I think I did 49 by 49. In actual use, it's usually much smaller pieces, different strips and stuff between other rocks and cliffs and things like that. But we found that this worked really well. Replacing the landscape with nanite meshes led to a massive improvement in performance. It's also a pretty good improvement in the detail as well. You can also mix and match these so that it doesn't look as uniform. So definitely a direction we're leaning, at least for now, while landscape has a lot of serious limitations in Unreal Engine 5. Foliage is an area nanite doesn't handle well, but we wanted to do a test to see if nanite grass was possible. Surprisingly, the results were better than we expected. Performance-wise, it was amazing how fast it ran. The main issue is that as the blades of grass get thinner, they start to disappear as they get further from the camera. You can kind of see this in this picture here. You'll notice there's kind of 3 levels of how dense they are, and that's the area. There aren't actually less, right? It's the same number evenly in the distance, but those are the areas where, because of the thickness of the grass, it stopped rendering them. So something to keep in mind. We did find, however, that we were able to find a thickness of a blade of grass that isn't too thick, but also renders far enough in the distance to render a large circle around the player. So we think that this is definitely promising. We're going to do some more experimentation about it. One of the great things about nanite is the somewhat constant frame rate, even when adding more and more meshes with complex geometry. However, overdraw is where you will see your performance drop. You can use the overdraw nanite visualizer to see how much overdraw is in your scene. For best results, try to not stack too many nanite meshes over top of other nanite meshes. We also found that the distance that you stacked them between each other had a huge effect. So if you stack two of them and they're fairly close together, that was bad, whereas once they're further apart, it was able to cull them and it wasn't as big of an issue. Many of the nanite meshes we experimented with were MEGASCANS assets. Unfortunately, they are huge. One MEGASCAN cliff that we were working with is over 1 gig in size. 75% of that size is in textures. MEGASCAN's assets are very large because photogrammetry uses huge textures, in this case 8K. Photogrammetry textures map each texel on a mesh with a unique pixel from a texture. This means that as the mesh surface grows in size, a larger photogrammetry texture is needed to keep the same texel density. And in many cases of large cliffs, there isn't much texel density. As you walk up to it, it's just a huge blur, as meaning that these cliffs could not be used in a place where the camera could get close to them, which is a problem. Large textures take up space in memory and on disk. One thing to look into is we ask the question, do we need to use a normal map if we are using nanite? The MEGASCANS assets do come with an 8K normal map, that in this case was 25% of the asset size at 250 megs. We did some comparisons where we loaded MEGASCANS nanite meshes with a normal map, without a normal map, and we found that there were very minimal differences. The one with the normal map accentuated the self-shadowed crevices a little bit more, but it definitely wasn't enough to be worth the increase in size. And so I would say to take a look at each individual MEGASCANS asset and check to see if you actually need that normal map. If you can get rid of it, it's going to save you a lot of resources. This also got us to thinking, what if we can get nearly the same look with a tiling texture plus masks for color tint? Also, if we did that, can we get more variation out of a single asset? So one of the guys in our team, Damari, did some testing and created a new method where we use a 1K tiling texture with a 1K mask for color tint to try to approximate the full 8K photogrammetry texture procedurally. What you're looking at here is the large rock on the left side is an 8K photogrammetry texture. It's from MEGASCANS unchanged, except it doesn't have the normal map. The large rock on the right side is a 1K tiling texture with 1K mask for color tint. And as you can see, it looks pretty similar. And there's more adjustment that can be done if certain details are missing. There's adjustments that can be done to try to get them added so that it does look even closer. There's a lot of adjustment that can be done to improve these and make these better. The other huge difference is that the rock on the left with the 8K texture is very blurry up close. You cannot get the camera close to it. But the rock on the right, because it has a 1K tiling texture that adds detail, it isn't blurry. It looks perfectly fine. Basically what we're doing here is that the 8K photogrammetry texture is being downsized to a 1K mask, and then a color picker is being used in the material to pick out specific colors to drive a material layer blend. We're using the material layer system in Unreal Engine, which exists in Unreal Engine 4 as well, and is really, really great. I highly recommend this workflow, especially for small indie developers. But we're using the material layer system, and so we're using these color picker from this mask where you pick a certain color and then it selects a range around that color and then can tint the underlying texture to try to pick up all of the color variation from the original in the procedurally generated one without having to keep the 8K texture. Now keep in mind that an 8K texture is 64 1K textures. It's not 8 times the size, it's 64 times the size. And so in this case, with a 1K tiling texture plus a 1K mask, we reduced it by 32 times. So it's a massive savings, and this is a savings on disk for the shipped product, but even more importantly, it is a savings in video memory. It was huge. We went from somewhere in this one demo here, it's got about 5 cliff rocks. We went from using somewhere around 2400, so 2.4 gigs of video RAM, down to about 600. So huge savings. We're going to be doing more experimentation into this, but definitely something to look into if you're worried about the size of MEGASCAN's assets, and it's definitely something that we're worried about. LUMEN is the global illumination solution we have been waiting for. In the past, we tried light propagation volumes and VXGI, and we determined that neither of them were a viable solution. But for high-end PC hardware, LUMEN is definitely viable. This fixes our issue with transitions from outdoor to indoor and indoor to outdoor. They look great with LUMEN. Having caves or buildings you walk into in your open world scene, it just works now. It's great. Really awesome. To be able to get this to work correctly, though, you're going to need to use meshes that are modular. It only supports meshes with simple interiors. So walls, floors, and ceilings need to be separate meshes, right? You can't combine them together. So you have a wall, don't mix a wall and a floor, or a floor and a ceiling, or a wall and a ceiling together. You got to use small modular pieces. Also, large single meshes are not expected to work with LUMEN. This is from Epic, and so everything needs to be built modular. No big giant meshes. Well, if you're wondering what big giant mesh means, I would try to keep stuff under no more than maybe 30, 40 meters for a single mesh. One of the things we ran into is that we noticed that a lot of times it seemed like LUMEN wasn't working. Light was not being bounced, and it just wasn't looking good. And we found that that was because the base color is used to determine how much light to bounce. And so in the base color in the material was too dark, light would not bounce. And so if you're having that issue, be sure to boost your base color so that it will reflect more light. We had to kind of go through and boost just about all the base colors by a factor of 2 to get it to look right. So it's definitely something to adjust there. Here is what Epic recommends to use for dynamic lighting based on the platform you're targeting. So for high-end PC and next-gen console, use LUMEN. For mid-spec PC and last-gen console, you're going to use distance field shadows and distance field ambient occlusion. And for mobile, you're still using non-shadowed skylight. Virtual shadow maps allow high-resolution dynamic shadows specifically designed to work with NANITE, LUMEN, and World Partition. Virtual shadow maps replace a mix of different shadowing techniques that had to be blended together and often resulted in a poor final product. In the past, we had a lot of trouble with cascade shadows leaking through geometry, and blending between cascade shadows and distance field shadows was always noticeable. Now we just turn on virtual shadow maps and it replaces the existing methods in one unified solution. Virtual shadow maps are very important because they are what allows highly detailed shadows on your highly detailed nanite meshes. So if you don't have virtual shadow maps, nanite's just not going to work. That really, nanite, LUMEN, and virtual shadow maps, they work together. They're all interconnected. I don't think you're going to have a lot of luck disconnecting anyone from the other one. They work together as a package. They're specifically designed to work with each other. When using virtual shadow maps, it is important to make sure that shadows are not changing from frame to frame. This is very important in cases where you have a time of day system. So you got to make sure don't move the sun angle every frame, right? If you watch my time of day video for my tutorial series, you'll notice that we had it do it every other frame or every 4th frame or every 8th frame, every 16th frame, whatever it was. You know, I think with virtual shadow maps, you're going to want to go even longer than that. You're going to try to go as long as you can between updates without it looking like the sun is jumping, right? So you got to play around with how fast you want your time of day to rotate. You know, like, is it an hour a day, 2 hours a day, 4 hours a day? You're definitely not going to want that too short. Go as long as you can get away with, and then make sure to move the sun angle as little as you can so you don't invalidate the cache on the virtual shadow maps. Otherwise, you're going to have terrible performance. Virtual shadow maps work best when there is just one direct light for the sun. If you have additional lights, be careful about how large of an area those lights cover. Also, be careful about number of lights. In Unreal Engine 5, there is currently an experimental mode called one-pass projection to increase performance in scenes with multiple lights. One-pass projection is experimental, but will become the default path in the future, according to Epic. With one-pass projection, there are a maximum of 10 shadowed lights per screen tile. While virtual shadow maps can run on DirectX 11, the performance is very bad, so I would consider this a DirectX 12 only feature. Other new or improved features in UE5 is the enhanced input system. This is really cool. They have examples of it in the Valley of the Ancients demo, and they have it connected to gameplay abilities, so definitely something to look out for there. Motion warping is looking really cool, but we are worried about it in multiplayer at this point. Currently, motion warping only supports root motion anim montages. It does not support root motion gameplay tasks. Now, Epic has said they want to make it work for root motion gameplay tasks, so we may have to wait for root motion gameplay tasks before that becomes viable for multiplayer. More testing on that is needed to be sure. Temporal super resolution. This is important for those who can't run DLSS because they do not have a video card that supports it and want to run higher resolutions than HD. Nanite scales on screen size. As your screen size goes up, your Nanite performance drops very quickly. And so what you want to do is you want to render less pixels and then upscale them to more pixels. So temporal super resolution can do that if you can't support DLSS. DLSS is definitely better. It produces what I consider to be a better final result than native 4K. Particularly around less blurring as you move because of the temporal AA. And the performance on DLSS is significantly higher increase than the temporal super resolution. But the temporal super resolution is still pretty good, and the loss in quality seems to be fairly minor. I don't believe Control Rig and Full Body IK changed in Unreal Engine 5, but I wanted to point it out. There are examples in the Valley of the Ancients demo, and so you might want to go take a look at that. A lot of cool stuff going on with that. I think that's going to be huge in the future, especially for small indie devs where creating animations is, too resource intensive or costly. MEGASCANs is really cool. It's going to replace sound cues. And so at some point, sound cues are going to be removed from Unreal Engine 5. So definitely start moving toward MEGASCANs. And then also in the Valley of the Ancients demo, they showed us an example of gameplay features and modular gameplay. This is a way where you can develop game features and gameplay in separate projects and in separate modules in a certain way where it organizes them separately and separates the concerns. And now when you pull them into your main project, they'll just work, right? And so I recommend looking into that methodology. I think that's going to be a good way to go in the future. Current Unreal Engine 5 limitations. So there are limitations around the landscape, foliage, water, deforming meshes, and world partition HLOD'S. Landscapes are not represented in the LUMEN scene. And in one of our tests, we noticed that tree shadows are darkened even further on landscapes by enabling Lumen global illumination, which is backwards. But tree shadows on nanite meshes are lightened properly when enabling Lumen global illumination. So landscapes just are not working correctly for shadows. They got a lot of weird lighting artifacting. The performance is terrible. They don't support world partition HLOD'S. So at this point, I consider landscapes not usable in Unreal Engine 5 Early Access. It's just going to be problematic on too many fronts, from performance to lighting artifacts. The good news is, according to Epic, there should be a solution for these issues before 5.0 launches. So that's great. Mask materials are treated as opaque in Lumen and cause overshadowing. We were really worried about this one, but it ended up not being that big of a deal. I think that you'll notice it more in meshes where you have sparse foliage, right? Where a lot of light comes through the leaves. But in our case, most of the trees and bushes and stuff we had, other than maybe small areas around the fringes, the light really wasn't coming through. It was blocking them. And so treating it as opaque for lumen and grading overshadowing, it really wasn't noticeable. I wouldn't worry about that. The good news is, in our testing of masked material leaf plane foliage, the performance was acceptable in Unreal Engine 5 with Lumen and virtual shadow maps enabled. We were worried that it would be problematic, but it is expensive. You have to be careful with foliage and how dense it is, but it's definitely acceptable. We're still experimenting with fully polygonal foliage, and we played around with the grass, and that's looking like it might work out. But we also want to look into bushes and trees. We're thinking that potentially we may have to go a hybrid approach where the trunk and branches of the tree allow us to have a super detailed nanite mesh, and then we still have to use masked material leaf planes for the leaves, because at this point we can't think of any way to make a leaf plane work in nanite. Water has the same issues as landscape. It is a landscape. Water is not represented in the lumen scene. Water requires a landscape, but this is expected to change. So that's going to be great when that happens. And then world partition HLOD'S, just like landscape, do not currently support water. Virtual shadow maps. They work off a cache, and they have trouble with vertices that move. And the most likely place that we're going to have moving vertices is on skeletal meshes. And that's a problem. I think this is primarily a problem, and this may be a reason that you can't use these new features, is if you're going for a very high player count multiplayer game, right? If you're building a game where you're like, I want 100 players on scene moving around, I think you're going to run into issues. Now, we did some testing on it, and it didn't seem all that bad. I took the Ravager that we used from the tutorial series, and I arranged him in a grid, set an animation, and I think I put 64 of them in 8x8 grid. I might even have done 100 at a 10x10, something like that. And it wasn't as bad as I was expecting based on some of the stuff that Epic said. But I think that deforming meshes are definitely something we're going to have to keep an eye on performance-wise. One possibility is lower poly skeletal meshes, so there's less vertices moving, but I think this is a problem. If you think about it, with Nanite, we're creating a much more detailed world. If we lower the detail on our skeletal meshes, they're going to feel like they don't fit in the scene. So I feel like we actually have to increase the detail on our skeletal meshes to try to make them seem like they fit into this more detailed Nanite world. I think a better approach is to look into update rate optimization, or the new animation budget allocator plugin. And what these methods do is they basically don't update the animations every frame. And in particular, they update the animations on skeletal meshes further from the camera at a lower rate than ones next to the camera. And I feel like this may be a good way to invalidate less of the virtual shadow map cache. Another thing that we saw in the Valley of the Ancient demos is that they, for the giant robot, they use static meshes, which were nanite meshes, attached to the skeleton. So this might be something that you could look into for non-deforming armor, right? Maybe solid armor that doesn't bend. I know it's hard to do that sometimes and not get it to clip into other pieces, but definitely something to look into. Also, robots are a great use of non-deforming, skeletal meshes, because you can just take the pieces of the robot and attach them to bones and not have to actually deform any vertices. Should you switch to Unreal Engine 5 now? Here's a few questions to think about. Can you deal with the current limitations of Unreal Engine 5 Early Access? how far along is your current project? I think that if you're getting close to alpha in Unreal Engine 4, that probably it's best to stay on Unreal Engine 4 and just finish out your game with that, and target the users that you were targeting and the hardware you were planning on targeting, rather than trying to move to Unreal Engine 5. Next question you have to ask is, how hard will it be to convert your project to UE5? So it just depends. We found blueprints were not a lot of fun, and the world we gave up on trying to convert. C++ code moved relatively seamlessly, so no issues there. Which brings us to the next question. Will you start a new Unreal Engine 5 project from scratch? Something to think about. You may decide to start a new project, especially if you're starting a brand new world, and just pull in previously made functionality into the new project rather than trying to convert the Unreal Engine 4 project. And then you also have to ask a question we ask a lot is, will the new features in Unreal Engine 5 cause you to rethink your game design completely? And that's definitely something we are thinking a lot about, is how we can take these new technological features and convert them into fun gameplay elements for gamers. So definitely something to think about there when deciding whether you should switch to Unreal Engine 5. That's all I've got for now. If you have any questions or comments, please leave them in the comment section and I'll try to respond to them. And have a good one. See ya.